Hi, my name is Dr. Rambabu. I am working as an associate professor in the Department of Electronics and Communication Engineering. I am from B.V. Raju Institute of Technology, Narsapur. Our course name is Microprocessors and Microcontrollers, and our today's topic is addressing modes of 8086 microprocessor. Before we are going to talk about addressing modes of 8086 microprocessor, let's see learning objective of our today's topic. To understand and identify the various addressing modes used by the 8086 microprocessor to access operands efficiently in assembly language programming. This is the learning objective. Next, why study addressing modes? Here, the addressing modes help us to understand the types of operands and the way they are accessed while executing an instruction. Here, whenever we are going to write the assembly language programming, in different ways, here we are going to locate the data in a specified instruction. Here in different ways we can able to access the data by using the data at the same time memory addresses. Here the way of locating data or operands, that is called the addressing modes of 8086 microprocessor, that may be for 8051 microcontroller. Next, what are we going to study? We will see the types of addressing modes present in 8086 microprocessor. Next, we will study each addressing mode with example. This is very important. These two things we are going to cover in our today's topic. These are the types of addressing modes. Mainly there are 8 addressing modes are there. The first one is immediate addressing mode. Next one, direct addressing mode. Next, register addressing mode. Register indirect addressing mode. Next, indexed addressing mode, register relative addressing mode, and seventh one, base plus index addressing mode, and next last one, relative base plus index addressing mode. Now, one by one we are going to discuss with example. First, we'll start with the immediate addressing mode. In this addressing mode, here this is the programming instruction. Here, one of the operand. Here there are 2 operands are there, one is AX, another is the value. Here in these 2 operands, one operand must be the immediate data. This is called the immediate addressing mode. Here whenever we are going to execute this instruction, the 10ABH, this hexadecimal value that will be stored in the AX register. In that way, the AX register will hold 10ABH value in AX register.0Next, direct addressing mode. In this direct addressing mode, one of the operand, this is the programming example instruction, one of the operand must be the memory location. Here for example, if you can make the square bracket for a 16-bit number, here we are calling that is a memory location or that is a address. Here this 5000H is the address that holds some data. That data we are going to move into AX register. This type of addressing usually we can call as the direct addressing. Here one of the operand that must be a memory location. This type of addressing is called the direct addressing. Here this is the memory. Here 5000H, 5001H and 5002H, these are the memory addresses. Here 5000 holds the 22 and 5001 holds the 33. Whenever we are going to execute this instruction, this 5000 is contains 22 and 30, 16-bit number that will be we are going to move to the AX register. This is called the direct addressing. Next one is the register addressing. Here in this register addressing, these two are the example instruction. The two operands must be the 2 registers. Those may be AX, BX, CX, AX, AX, DX. In that, the 2 operands must be the 2 registers. If you can check the first example, here for example, if that is a 8-bit operation, AL, BL, these 2 are the 8-bit registers. For example, if that is for a 16-bit operation, AX and BX, these 2 are the 16-bit registers. The 2 operands must be the 2 different registers. Here the data can be, whenever we are going to write move AL comma BL, that BL value we are moving into AX AL register. If you are writing for a 16-bit operation, move AX comma BX, the BX content here we are going to move into AX register. Here we can check with the animation here. Here the BX contain 10ABH, here we are moving into AX. That is the 10A, 10 and ABH. This 16-bit number we are moving from the ABX register to the AX register. This is called the register addressing. Next one, register indirect addressing mode. Here, similarly, just like our register addressing mode, here those two operands are the two registers only, but one of the register that is going to hold address. Here we can check, this is the example programming instruction, move AX comma in bracket BX. Here BX register is a one general purpose register. Usually we can call this register as a base register. This register is holding the sum address. This register is holding the sum address. That address is going to point some data. That data we are moving into AX register. Here we can check, for example, this is the memory. Here BX register is holding 5000H. This is the address. That address is this is the address. The address is holding 22 value. Of course, that is a 16-bit number, 2233. Whenever you are going to execute the instruction, move AX comma in bracket BX, the 22 and 33 in AL and AH, in that way the data is going to be stored in our AX register. This type of addressing here we can call it as the register indirect addressing mode. Next one, index addressing mode. This is the example programming instruction, move AX comma in bracket SI. Here if you can check the operands, one of the operand may be any register, but the source operand must be any one of the index register, that may be SI or DI. SI stands for that is the source index register and DI stands for that is the destination index register. One of the operand must be that is the index register. Here we are writing, here we are using in that programming instruction SI, this is the source index register. Here you can check that operation. SI is the source index register that is pointing to some address 5000H. This is the 5000H. The 5000H contains some number. Here we are going to transfer that 16-bit number from the SI pointing address to the pointed data to the AX register. This type of addressing mode usually we can call as the indexed addressing mode. Next, register relative addressing mode. Here this register relative addressing mode, this is the example programming instruction, move AX comma 50H in bracket BX. Here this is just similarly just like a register indirect addressing mode, but here we are using one displacement value that is the 50H. Here just like register indirect addressing mode, the BX register holding some address that is the 5000H. 5000H is our address. This is the 5000H. And here we are adding some additional addresses. Here that additional adding address we can call as the displacement. Here we are going to add 5000H plus our adding address is the 50H. Totally we are going to get the final index address is the 5050H. Now if you can check in that memory, 5050H that is having some data, that data we are going to move into AX register. This type of addressing usually we can call as the register relative addressing mode. In that way, the AX is going to hold 33 and 44 in that AL and BL that splitted registers. Next one, base plus index addressing mode. The name itself that tells, here the operand that must be the combination of base register and index register. Here move AX comma in bracket BX and in bracket SI. Here BX is a base register and SI is a index register. That means here if you can check our 14 registers of 8086 microprocessor, here BX and BP, these two are the base related register, and SI and DI, these two are the index register. That means in this type of addressing mode, the operand must be the combination of base register and index register. Here the base register BX is holding some offset value 1000H. Our SI is the source index register is holding 2000H offset value. Here those two will be added. BX value plus SI value. Finally, we are going to get the 3000. We are going to get the 3000H 3000H memory location. This 3000H offset address is going to point to some data, that is 12H. That data we are going to move into AX register. Here in that way, we are going to transfer the data 3412H to the AX register. This type of addressing we can call as the base plus index addressing mode. And last one, relative base plus index addressing mode. Here if you can check the instruction, move AX comma 50H, BX and SI. Here if you can check the second operand, the second operand contains the 50H is the displacement value, adding additional memory locations, additional memory addresses, and BX is the one base register and SI is the our index register. Here if you can check here, the 50H is our displacement value. This 50H may be sometimes 8-bit displacement or that may be the 16-bit displacement. Sometimes you may use that is the 8-bit number or sometimes that number may be 16-bit number. We are adding with the BX register address, that is the 1000H. Next we are going to add here that BX with the our SI 2000H. Now additional displacement is the 50H. Next BX value 1000H and SI holding the 2000. Finally we are going to get a 3050H address. This is the final index address. This 3050H is hold some data like 12, the 34. That data here we are going to move into AX register. This type of addressing is called relative base plus index addressing mode. These are all the 8 addressing modes of 8086 microprocessor. Here with that here we can able to understand, that means what are the different types of addressing modes available in our 8086 microprocessor and with the examples. And finally here I am going to conclude with our today's topic with the learning outcome. After learning this particular topic, the students can able to understand, the students can able to get, this is the learning objective, learning outcome. The learning outcome of the addressing modes of 8086 microprocessor is the ability to effectively use and distinguish between different addressing modes to access memory and data in 8086 assembly language programming. This is our today's topic. We will meet in the next topic, in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.